Good afternoon. Today we are going to be in 2.4, which is the start of proofs. And we start with algebraic proofs, which is basically you just solving an algebraic problem and giving reasons why you did everything that you did. That's all there is to it. So as we look, I have some very basic equations over here on the left. X plus 5 equals 9, x minus 8 equals 12, and so on. And all that we are going to do is write what we do and then why we actually can do that, because with math everything has a reason. So as we look at the first one, x plus 5, we all are saying, oh, I know what we do. We subtract 5 from both sides and we get x equals 4. Well, in math there's a reason why you can do that, and it's called the subtraction property of equality. Okay, basically that means as long as you subtract the same thing from both sides, you have made a legal math move, and that's why you can do that. Similarly, down here, x minus 8 equals 12. We add 8 to both sides, and we get x equals 20. The reason we can do that is a property called not subtraction property, but addition property. We are adding something to both sides. And it's the addition property of equality. Okay, just keeping down here on the next problem, very similar. We know that in order to get x all by itself, we divide by 4 on each side, which would give us x equals 5. All right, looking at our pattern here, the reason we can do that is the division property of equality. And last but not least, down here we have x divided by 2 equals 3. Well, what are we going to do to both sides? We are going to multiply by 2 on both sides and get x equals 6, and that would be the multiplication property of equality. We are going to be using these properties over the next 10 or 15 minutes here as we get moving through algebraic proofs. So here are those properties just listed out for you. The addition property of equality basically says if you add the same thing to both sides, everything stays equal. Subtraction property of equality, if you subtract the same thing from both sides, everything remains equal, and so on down to the substitution property of equality, which basically means if you have your answer and you want to substitute it back in to make sure that it's correct, you can substitute a value back in and that would still hold true. And then the last property, just to remind us of, is the distributive property. You've used that quite a bit in algebra. And basically it says if you have the 2 on the outside here, you can say 2 times x plus 5 means 2x plus 10 equals 16. And the reason that you can do that, that's the distributive property of equality. Okay, so we are actually going to look at writing some proofs. The way a 2-column algebraic proof works is very similar to how we will be doing other proofs later on in the next chapters. Basically, it's called a 2-column proof, where you have one of the columns is the statement that you are making, that's kind of what you're doing, and then in the other column is your reason or your property or your definition or your theorem, and that's the why you can do it. So you're making a statement and giving a reason. So if we are going to look at this problem here, we have 3x plus 2 equals 23 minus 4x. The first thing that we always do is we write down our given information. So in our statement, I'm going to write what we know. I know that 3x plus 2 equals 23 minus 4x. And my reason that I know that is that they give it to me. So that is always called given. Okay, so then we just want to solve the equation. And in order to solve the equation, the first thing that I would do is I would add 4x to both sides. This is just me showing my work in this step right here. So now I have 7x plus 2 equals 23. When I give my reason, I always put it next to my result. So what I did was I added on both sides, so that would be the addition property of equality. I'm going to abbreviate that addition property. Okay, so then my next step, we're just solving out the equation here, is I subtract 2 from both sides. I get 7x equals 21. And what did I do to get 7x equals 21? I used the subtraction property of equality. And then in my last step, I'm going to divide both sides by 7, and I get x equals 3. Well, how did I get 3? I used the division property of equality. And that's basically how your algebraic proofs are going to work. You're given an equation, you do a step, you write the result and give your reason, do a step, write the result, give a reason. This is one of the other reasons why we've been saying over and over again, you have to show all of your steps. When we write these proofs, you have to show every single step. Okay, so here's just another example of one. 6x minus 11 equals negative 35. Step 1, we always write our given information. So we have 6x minus 11 equals negative 35. Seems a little repetitious because it's right above there, but we still have to write it down. And the reason we can do that is just because it's given to us. The next step, solving the way that you always do. If you add 11 to both sides, you get 6x equals negative 24. And what did I do to get that? I added. So I'm going to use the addition property of equality. Next step, well, I need to get x by itself, so I'm going to divide by 6 and get x equals negative 4. What did I do to get x equals negative 4? I divided with the division property of equality. Okay, we're just going to go through several examples here. This is another one. Variables are on both sides. So I'm going to start by just writing down my equation. I have negative 2p minus 9 equals 10p minus 17. That's given to me. Okay. Then I look, all right, what am I going to do first? Well, I should probably get my variables all on one side. So I'm going to add 2p to both sides. And my result is negative 9 equals 12p minus 17. Well, what did I do to get that? I added to both sides. So that's the addition property of equality. All right, moving on. I'm going to keep going. I'm going to add 17 to both sides. And I get 8 equals 12p. Well, what did I do to get that? I added. So again, it's just the same reason. It's the addition property of equality. Last step is I divide both sides by 12. And I get 8/12 equals p. And how did I get that? I divided. So it's the division property of equality. The last thing that we can do is we can simplify. Okay, well, 8/12 simplifies to 2/3 equals p. Well, how did I do that? Well, really all that we did was we simplified a fraction, so we can call that simplify. Anytime we simplify or combine like terms, we can just call it that. If we simplify a fraction, we would just call it simplify fraction. If we combined like terms in a problem, we would say combined like terms. Okay, we got a couple more here. This one is very similar. You want to take a minute, pause the video, see what you can come up with on your own, write out the proof, and then see if you agree with the way that I did it. So we're going to have our statement and our reason. So go ahead and pause the video. And then once you play again, hopefully you'll be able to follow along and you will have something similar to what I have. Here's my statement. And here's my reasons. So go ahead and we're just going to rewrite the problem. 39 minus 5z equals negative 1 plus 5z. And that's just given. Okay, first thing that I would do is I would add 5z to both sides. I want to get my z's on both sides. If at this point you moved your z's over to the left by subtracting 5z from both sides, your numbers might look a little bit different, but your reasoning should be very similar with the adding and subtracting properties that you can use, but your signs might look a little bit different throughout your work. So we're left with 39 equals negative 1 plus 10z. Okay, how did I get that? Well, I added 5z to both sides, so that's the addition property of equality. And then, what am I going to do? Well, I want z by itself, so I'm going to add 1 to both sides, and I get 40 equals 10z. Well, what did I do? I added again, so that's the addition property of equality. Last step, I want to divide both sides by 10. I get z equals 4, or 4 equals z, and all I did was the division property of equality. Okay, so take a look if you paused the video and tried to do it on your own. Hopefully you came up with something similar to that. Over here on the right, we have one that's going to use the distributive property. So let's go ahead and work our way through that. I would like for you right now to pause the video, work through it, and then see if you come up with the same reasons that I do. Okay, so take a look at what I have and compare that with what you have and see if you agree. First thing you had to do was use the distributive property. Then we added 40 to both sides. Then we divided both sides by negative 35 to get w equals negative 2. Now you should be able to go into big ideas and find your homework to work on that will be due tomorrow. Have a great day.